Morning, guys. Today we're gonna be looking at a roof. Okay, so this is info roof. So basically, the question goes like this: it says, refer to the diagram sheet attached. The roof plan and a section of an outbuilding are given. So you're gonna analyze the roof just now, the addendum there. Then it goes like timber roof truss. It is made up of 114 by 038 printed set South African pine. Trusses are spaced at 750 center to center. And then 114 by 38 whole plate. We have 50 by 76 millimeter swan paling, and we have 76 by 76 rod eve paling. Okay, we've got corrugated fiber sheet, roof covering, adjustable ridge, and ridged final board fascia, ridge fascia. 32 by 220 swan South African pine fascia and birch board. The pitch of the roof is 30 degrees. We have a brick wall of 220, meaning one brick wall. Then we've got question 1.1, which talks about the gable wall. Then we've got 1.2, which talks about a timber. Then we've got 1.3, which talks about a timber but the roof truss. Okay, so let us analyze the drawing. Okay, so the roof is given like this: from corner externally to corner externally of the brickwork, it's 8,000. We've got an overhang of 400. On the gable side, we've got an overhang of 200. The width of a building in brickwork, external to external, it is 3,100. Okay, then we've got we've got a section here which shows the overhang of 400. We've got a tie beam, a South African truss. We've got a 2.8 rafter. Okay, other measurements are given there. We can clearly see that we've got a beam filling, and also we've got a wall plate under a truss. Okay, there is the dimensions of a beam filling there on the side, 270. The highest height of a beam filling, the lowest is 190. Okay, so that's the drawing. Now let us get to see what is the first question. Okay, so they say measure the brickwork on the following item: the gable wall. Now, what you need to understand about a gable wall, it's made up of two shapes. Okay, we've got the rectangular shape, and also we've got a triangular shape. So when you describe, okay, remember this is a dimension paper, consists of a timesing and also a dimension, Google squaring, then a description. Okay, so on the description, this is where you will describe your wall. Okay, this is one brick wall on gable ends. Okay, so I drew the shapes of a gable so that you can understand. Now, what you see here, it's a triangle on top, and what you see at the bottom, it's a rectangle. This rectangle, it's of a beam filling. Okay, so it also appears on the gable end. So now, because of a gable end, I need to understand the height. So when we analyze the drawing, we can clearly see that the height of a roof truss is given there at the king post as 1020. Okay, but we know that this is sitting on a thickness of 38 for a wall plate. So when we look at a brickwork on gable ends, it will start below 38 of a wall plate, which means that 38 of a wall plate is part of the height of the brickwork on gable end. Okay, so come back here. We have this 1020 of a roof truss, we need to include, that is why we are adding, we include 38 because it's part of the brickwork of the cable end, so that we can have 1058. Okay, so that's the height of the brickwork, the overall, including the triangle and the rectangle. Okay, so how we measure this, we come here. Remember, when we measure a rectangle, we need to follow a order of our dimensions, né? So it means the length taken from, this is the cable side, and also this is the cable side. Okay, so in this cable side we have this measurement 3.1. okay, that is why you see 3.1 here. That's the length. The height, it's given here. Here's the dimension of beam filling. We take the highest one. Okay, so this is it. So as we are taking this one, this is a rectangular or an area of a rectangular brickwork on the cable end, and it is of a height of a beam filling. Now this is one side. 3.1 times 0.27, it's one side, because we have two sides in the building. That is why we multiply by 2. Now, since we are done with a rectangular, now we need to start doing a triangle. And we all know that the formula of a triangle says half base times a height. Okay, even when we express the dimensions here, we need to follow the formula to indicate that it is a triangle. Okay, so that is why you see half, our base is 3.1 and our height is 0.79. How did we come to 0.79? Remember, the overall height of a rectangular and triangle is 1058. We minus 270 simply because we have dealt with 270 first. Now, to include the triangle alone, out of this overall height, we need to subtract 270 so that we can be left with 788. So in meters, this is going to be 0.79. Okay, done about the brickwork, because once you say half base times height, you need to say times 2 to include the other side. Okay, so the next question says, let us do a raking and cutting. Okay, so to do a raking and cutting, this is what you're gonna do. You're gonna indicate that you are doing a raking and cutting. When we build that triangular shape of a brickwork, we are using a rectangular bricks, which will leave us this shape of our steps, okay, on both sides. So for us to get a clear triangle out of this shape, which are our steps made up of a brickwork, we need to cut this projection so that we can have a smooth triangle like this. Okay, if you are using bricks, you can't simply get this smooth triangle. You will get something like this, but you will have to cut this raking, né? That is why we are doing the raking and cutting. Okay, you're gonna remove this raking, okay, by cutting. Okay, so that is how we get this smooth triangle. So I drew this so that you can relate to what I'm saying. So this thing is measured by a linear. Okay, so if we measure this in linear, how much is this side of a triangle? There you go. This is the size of the triangle. It is 2050. Okay, so we come back here. We have 2050. This is just one side. So to include this other side, we're gonna say times 2. That is just one side of end of a cable, ne? So to say there's an opposite side that look like this, you want to say times 2. Okay, this is 2050. To include that within this triangle, we have two sides. That's the first 2. to include that there is an opposite side on the building. That's the other two. I need you to understand that. Okay. Then the next question says, let us do a beam filling. So when we do beam filling, okay, so this is the Gable side and also that's the Gable side. So when we look clearly here, as you see what I draw here, this is the end of a Gable. This is also the end of a Gable. Where you see these lines, that is where you will find the beam filling. It takes the internal measurement. Okay, that is where you find the beam filling, because on this side we have a Gable and the brickwork. Okay, so if we understand that this is the length of a beam filling, then we come back and see we have a beam filling to a length of a building. The length is 8,000 external to external. For us to come to internally, we need to subtract minus 2 times 220, which gives us 440. Remember, the 220 we are talking about, that's the first one. The second one is on this side, which makes 440. Okay, so now with that, we then say, if we say 8,000 minus 440, we are left with 7,560. Okay, then we take this, we come here. We say the length is 7,56. Now the height of a beam filling is 0,27, given there. Okay. Then this area is for the one side. If it is the front side, at the back also you find one and the same thing, because we have an opposite side. That is why we say times 2. Clearly, that is what we're going to be doing. Then the next question now, it says measure facings on a beam filling side. Now guys, I need you to understand this. What are the facings first? Before we determine the measurement of the facings, what are the facings? The facings are the pattern that we see on the elevation side. Okay? Are the pattern that we see on the elevation side after the building has been erected. Okay. So since we are looking at this brickwork, clearly we can see that how the dilemma bricks here. We've got a stretcher bond, we've got a header bond, we've got a stretcher bond, we've got a header bond. You know what that means? It means they build this wall using English bond, because that's the pattern of English bond. How I'm determining this? I'm determining this by looking at the facings. How did they lay my bricks? It's 220 one side, 220 one side. That gives me an indication of English bond. Okay, so since that's the English bond, those are the facings. What I see are the facings. Okay, so let us get back to the question. So since we understand the facings now, you describe these are extra over ordinary brickwork for facings. Why are they extra over? Because we have dealt with the brickwork alone. Okay, we are still measuring the brickwork now, but for the second time. So since we're doing it for the second time, this becomes the extra over, because it's not the first time we're doing it. Okay, so that becomes extra over. Now we understand the facing. So when we look at the beam filling, remember I said at the gable end we have a rectangular shape of a brickwork which stands for a beam filling, okay, before the triangle side. Now even on the gable end we have the brickwork for a beam filling, while we have a beam filling also on this side. So now look here, the beam filling we measured as a brickwork starts from internal measurement. That's what we said, that's what we did. But now when we look at the pattern of the brickwork, it starts from external to external. Okay, so I hope that is understood. But external to external, those are the facings. Remember, we said there is a brickwork here on the beam filling side. The pattern of a beam filling doesn't start from internal, because we also have the brickwork in beam filling as a rectangular here. Also we have it here, so we have it all around basically. So that is why we're gonna be taking 8,000 as a length, not 756. So now we have what? 8,000 times 0.27. Then that's the front side. To include the back side, we say times 2. Okay? So we are done with 1.1. Okay? Then we off to 1.2. Measure the timber on the following item. We first have to measure a wall plate. Okay, so here we were told that the wall plate is 114 by 38.